So over here in this video, we are going to create a Chemkin file. Okay, so entirely by scratch, you don't need to install Chemkin to create this kind of file. So this kind of file is necessary where, like you are suppose you are doing an analysis where it involves the reactions also, not the flow. In the flow, actually, the reactions are simultaneously being taken place. So this kind of files are important because we need to give the software the reactions. So over here, this is actually very helpful. Suppose you want to do a simulation of some sort of reaction that the preloaded software, that is the Ansys Fluent solver, does not have preloaded actually. So in order to do that, previously you have to go to that Chemkin and then simulate this Chemkin and then simulate the reaction over here. But in a simple form of coding also you can simulate the reactions, and it's very easy actually. So first of all, you'll write over here elements. So over here are elements. Suppose we are simulating the methane reforming reaction. Okay, so first of all, in the reaction over here, first of all over here you'll write elements. Okay, and specify the elements which are present. So suppose in this reaction only carbon, hydrogen and oxygen is present. So over here I'm specifying carbon, oxygen and hydrogen. I'm then ending the comment. Okay, so elements carbon, oxygen, hydrogen, then end. Okay, species, then you have to specify your species. In the species part, see over here there is our methane. Okay, in the reaction there is our methane, there is our water. So in the species we'll write water. There is a carbon dioxide, so we are specifying carbon dioxide, and there is a hydrogen, so we are specifying hydrogen. So note that in the species element section or the element section, you'll not write any coefficients. So over here the coefficient is 2, or over here the coefficient is 2, you will not write that. Okay, so now after you specified species, then you will end the command by giving a short end over here. Okay, so now coming to the reactions part. Okay, so you know the reaction, so write the reaction over here just. Okay, write the reaction, then you need to specify two things. First of all, there is the activation energy for the reaction. So this is the activation energy for the reaction, 6.456 10 to the power 21. So E is for 10 base. Okay, then write zero point 0. Okay, so this is the code you have to write, zero point 0. Now after that, this is the rate constant K. Okay, so the rate constant, not the rate constant K, it is the rate. So over here, this is the rate constant K naught. Okay, so K naught is the pre-exponential factor. So this is the pre-exponential factor actually. So for a specific reaction, you can get the pre-exponential factor according to your requirements, according from the net also, but it will be mostly provided to you. So after the reactions, after ending the reactions, end. Okay, so you have successfully created a Chemkin file, which was not present in the Fluent actually before preloaded Fluent. So over here again we are launching the Fluent launcher. So okay, so first of all you have to click on double precision and then launch the launcher. Okay, so then the launcher will be launching. Actually, what is happening over here? So first of all, this is our methane inlet. So over here, from this point to the midsection of this line, actually. So that means to this point, actually, methane is entering in this reactor. Okay, and from the middle point to the ground point, the water vapor is entering. So the methane and water vapor are actually entering, and reaction is actually taking place in this reactor. So what is actually happening is that the reaction is taking place, and the products are being formed. In general, what happens is that if you don't specify the reaction mechanism, the Fluent solver will not take that into account. It will not take anything that is being forming into account. It will just create this as non-reacting species. So when you don't specify the reaction, what Fluent does is that it will not create the product, but it will just create how these two flows will interact with each other. So this will only create that, but it will not take into account the interaction of the product with these two elements. Okay, that is your methane and water vapor. So for that, what you need to do is that you have to import your Chemkin file. So uh, let me just solve this. So this is an axisymmetric pipe. Okay, so then what you going to do is that, so in the models actually. So first of all, I've turned on energy equations, and since our paper was on k epsilon method for viscous this viscous model, we have turned to k epsilon or 2 equation, which is a pretty standard model. You can also turn on laminar, which will take into the laminar flow. So like it will depend from case to case. Okay, so now on species, now what the magic happens actually. So first of all, this is the species part. Okay, so see in the mixture material of now, if you just click on this, there is only methane here, nothing else. Okay, and if you just turn on it from the scratch, there will be very few options in the mixture material. Not every reaction is taking place in the mixture material. Okay, so another thing that you keep to why we are turning on the species model is that, see over here there is methane, over here there is methane, and over here there is water vapor. Okay, and the products are actually carbon dioxide and your what hydrogen. Okay, so that means there are four species that are taking place in the reaction within this, actually within this reactor. Okay, so that means you have to turn on species transport. The species transport will take care how is the conversion taking place. Okay, so that means the species transport will give you that at this length, that is at x equal to 0, our methane was 1 unit, 1 mole of methane, and water vapor was 1 mole of methane. Okay, 1 mole of water vapor. But suppose at this cross length, okay, suppose at x equal to l by 3. Okay, so over here what will take place is that there will be no longer 1 mole of methane and 1 mole of water vapor. Why? Because there will be your some sort of reaction, and over here some reactant will go and some product will also form over here. So that means over here in this cross section, four elements will be present, four species will be present. So that means you have to turn on species transport. The species transport does is what is, it calculates the species at every length of the like of the fluent reactor. This is the reactor, it is calculating the species composition at every length, and for that you need to have the reaction mechanism. Okay, or otherwise Ansys will not understand that. Okay, so first of all click on reaction mechanism, then you will have the kinetics file. So first of all browse. Okay, so then select the file that we have saved. For my case, I have saved the file in my desktop, and first of all make it all files, then reaction.make.txt. Okay, so that means this as the input file, it has been selected. Now click on import. Okay, so now it is, what is doing is that now this is importing the file, and it is analyzing that how the reaction is being taking place. Okay, so right off the bat, they are saying that there is mass imbalance in the stoichiometry. Okay, first of all, now what you need to do is that we have to click on eddy dissipation. So why we are clicking on eddy dissipation, it is allowing us to know the rate of the reaction, calculate the rate of the reaction, and the reaction should be volumetric. Okay, and over here, so now what you need to do is that click on edit. So it will open up the import, like the Chemkin import. Okay, so that means what you need to do is that now click on reaction. Okay, click on reaction, and you will have the edit panel. Now you have, voila, now you have the species and the the reactants and the species which is formed. Okay, so that means why is that showing an error? Because see, yeah, so over here what is happening is that 1 mole of CH4 reacts with 2 mole of water. It gives 1 mole of carbon dioxide, but it gives 4 mole of H2. Okay, and in the Chemkin file there was 2 mole of H2. So that's why it was showing the mass imbalance in stoichiometry. Okay, so that over here now we'll click OK. The pre-exponential factor, I have specified that in the reaction it is taking that, and the activation energy which I have specified in the reaction. So now what you can do is that over here, so suppose you want to change the reaction pre-exponential factor of the activation energy, you can also change that. And when you change over here, the file that you created previously, it will also get changed. So keep that in mind also. So yeah, so over here now you'll click OK. Okay, so over here the reaction is finite rate reaction, the mechanism we have imported. Okay, so that means over here cross, then again over here select eddy dissipation. Okay, eddy dissipation calculates the rate of the reaction. For chemistry solver, you can do to like relax to chemical equilibrium. So over here it will solve till the chemical equilibrium is achieved within the reactor. Actually solve that. Okay, so that means over here you can now apply it. Okay, so over here actually see, you can see now in the materials import. So previously I had actually imported this material, so that's why this is showing, but this will not show when you import this your material. So over here see that in the Chemkin import we have all the materials that we have wrote in the text file. Okay, so that means you can create any equation, you can analyze any reaction with the help of a simple coding that we did previously. Not just coding, it's just simple instructions followed to be followed by the fluent solver.